atoms and molecules, and we will continue with that chapter. Can you listen everyone? Can you hear everyone? Can you hear everyone properly? Okay. Okay, so last day I have told you about the preliminary idea about molecules and what is homonuclear molecules and heteronuclear molecule. What is the difference between homonuclear and heteronuclear? For example, nitrogen and ammonia. Nitrogen, here the atoms are the homonuclear, ammonia it is heteronuclear. One example of heteronuclear molecule, that is calcium oxide. Here one calcium atom and one oxygen atom are bonded with each another to form the compound, that is calcium oxide. Hydrogen, they are homonuclear, and heteronuclear, that is different examples, that is copper sulfate, etc. Okay. Now today the important part is that what is atomic mass? Atomic mass. So obviously from that word, the combination of that word, that is the mass of an atom, mass of an atom. This is the meaning of that term. Now how to calculate mass of that atom? How to calculate the mass of an atom? Now as the source is different, because just for example, the atom of nitrogen, an atom of nitrogen, an atom of oxygen, an atom of hydrogen, an atom of calcium, an atom of magnesium. So the sources are different because they the species having different characteristics within itself. So for this we have to take a relativity. What is this? That is, just make a comparison with a fixed one. For example, just we calculate, suppose give one example, suppose 10 centimeter. So 10 centimeter, it is with the reference of 1 centimeter and it is the multiple of 1 centimeter. Okay, so 1 into 10 times, that is called the 10 centimeter. We know it from the mathematical calculation. Here also we will take one reference. What are the references? The references are different. Somehow we will take hydrogen, the atom of an hydrogen or weight of an hydrogen atom. Sometimes we will take the carbon atom. Sometimes we will take the chlorine atom. Okay. So these are the different references, that is hydrogen atom, carbon atom, chlorine atom, and also there are also references, that is oxygen atom, etc. Okay. So what is the mass of an atom? That is how much, what will be the proportion when we divide by the mass of an atom divide by the hydrogen, the mass of an hydrogen atom. Now this part is given on the page number 34. This part is given on page number 34 of your science book. Everyone open page number 34 and follow the right column where the atomic mass is given in the section 3.2.2. So relative atomic mass of an element, so relative atomic mass of an element is equal to the mass of that species divided by mass of one hydrogen atom is equal to mass of one atom, mass of an atom of that element divided by mass of one hydrogen atom. So, this is one reference. Mass of an relative atomic mass of an element is equal to the mass of an atom of that element divided by the mass of one hydrogen atom. It is the mathematical expression of relative atomic mass of an atom. Now, why this is called relative? One example. So, when just take the example of 10 centimeter. Now, here the centimeter is the reference. So, we know 1 centimeter is having a definite length. Now, when it is comparing with it 10 times, then it becomes 10 centimeter. Now, here also the mass of that particular element will be compared with hydrogen. Now, what is the necessity of that? In this way, if we compare all the mass of an element individually, then we will get a standard, because this the lower half, that is the lower half, it is having a definite value. So, every time we are dividing it by a suitable number. Okay. So, this is for the standardization of the atomic mass. Now, this atomic mass is later on called as AMU, atomic mass unit. In the same way, if we calculate it with respect to the carbon, then we have to know about what is the atomic mass of carbon. Carbon having atomic mass of 12. Now, here the mass of one hydrogen atom is 1. So, here just I am writing down the next expression, that is mass of an element, mass of an atom of that element divided by 1/12 of mass of an 1/12 into mass of an C12 atom or carbon atom. This is on the carbon scale, this is on the hydrogen scale, this is on the carbon scale. If we take chlorine as a reference, then it would be the 1 by 35.5 into mass of a chlorine 35 atom or chlorine atom. Okay. So, this is about a comparison, that is from their relativity terms is here, that is we are comparing with some standards. Here is that reason. Next one is that if we take it for oxygen, then it would be, suppose just we are calculating the atomic mass of an oxygen, then the mass of 1/12 of the mass of an hydrogen atom or 1/12 of the mass of an carbon atom, then it would be, just for example, we know the atomic mass of oxygen equal to 16. Okay. Now, 16 divided by 1/12 of the mass of a carbon atom, that is 12. So, it would be 16. For any other atom, if we compare it with hydrogen, then what would be becomes, because 1/12 1.008 or approximately 1/12 into 12, that is 1. So, in this way the atomic mass is calculated by different scale. These are called, this is called hydrogen scale, this is called carbon scale. Okay. So, this is about the atomic mass. Okay. Next one, this unit is called as AMU also, atomic mass unit, and later on this was converted to a single word, that is U. U is also is the replace of AMU, atomic mass unit. Clear? So, this is the about hydrogen scale of calculating atomic mass and the carbon scale of calculating atomic mass. Understood? Understood, students? Okay. So, this part, that is what is atomic mass. Now, carefully follow that part, that is section 3.2.2. Okay. And if you find any type of difficulty, then you will make me questions regarding to this section. Now, next part, that is what is an ion. What is an ion? Have you heard about this? What is an ion? Ion. What is an ion? Now, first of all, ion is that it is charged species. Charged species. Now, as we discussing about atoms and molecules, so here the charged species obviously will that of the element. Okay, so it is a part of an element. Part of an element. Okay. Now, what would be the part of an element when the ions will be there? So, when we know the charge species, what type of charge is this? Subtermine, it is plus V and minus V, that is positive charge and negative charge. Now, when an element, that is a single atom or a combination of atom, a single atom or a combination of atom carries any type of charge, then it is called as an ion. Suppose a single atom or combination of atom carries charge itself. Single atom, that is Cl, chlorine, it is, when it is represented in the anionic form, it is called as chloride, and the symbol is that Cl minus. Combination of atom, suppose one example, that is NH4 plus. Here the combination of atom, that is at the same time one nitrogen atom and 4 hydrogen atom, and carries a charge within itself. What is the reason of this charge? It will be discussed later on when we will come about the bonding. But here the charge is there, and charge is resides on the central atom. Here the central atom is chlorine, only one atom. Here the central atom is nitrogen, so it is the charge on the nitrogen. That means some type of deficiency in the electronic charge, and when the electronic charge, that is the availability of electron will be increasing, then its normal state, then it will come with the minus sign. And when the deficiency is there in finding electrons in the periphery of that central atom, then it will be called as plus charge. Okay, so this is the about the chemistry of that charged particle. So, ion is that charged species or charged particle. What type of charge? That is plus or V or minus V, that is positive or negative. Here is the example Cl minus NH4 plus. Some examples, that is combination of atom PO4 3 minus, this is called as phosphate, this is ammonium, this is chloride. Another one example, that is bromide, Br minus, I minus, these are also charged species, and one single atom is there. Here combination of atom is there. Okay. Later on you will come about this. This is the this portion, that is called complex conjugate. Okay. Now coming to that section about the definition. So, when a part of an element or any species that carries positive or negative charge, which is by origin it is the part of an element, then it will be called as an ion, and also the definition will be there in your textbook. The charged species are known as ions. Okay. Now, the charged species and you will elaborate to some extent that the charged species, that means the charged particle which is maybe one atom or a combination of atom. So, you will write it in this way: a single atom or combination of atom when carries charge, within bracket you may write positive or negative, carries charge positive or negative, is called as ion. And then you will give the example. So, a single atom or combination of atom when carries charge positive or negative is called an ion. Okay. This part is there. Now, coming with the example of some ions. Now, you will write it in your copy or etc. That is, first of all make a chart like that, making a column in the, it is monovalent. Okay. First of all, write down the positive charge carrying species, and this is also called cations, and in this column you will write negative charge carrying species, and within bracket you will write anion. Now, we will move to the example of that. So, first one, hydrogen ion. In bracket you will write H and the plus in the superscript, as a superscript with its symbol. Next one, sodium ion, and within bracket you will also mention its symbol Na plus. Calcium ion, within bracket you will write Ca2 plus. Another one you will write silver ion, within bracket Ag, capital A, small g, and plus as a superscript. Next one, I am moving to the example of some negative charge. First of all, it is chlorine ion. Formula is Cl minus. Next one, sulfide ion. S as a superscript, it is 2 minus. Another one you will write hydroxide ion. OH minus. Nitrate ion, NO3 minus. So, in this way we will represent different species. One is cation, another one is anion. Okay. This is about the examples of cations and anions. Next one, that is valency. It will not be completed today. So, what is valency? So, valency is that capacity of an element, capacity of an atom to bond with another species, to bond with another atom. Now, here also we will take some references. What are the reference? So, first of all we will take hydrogen, chlorine, etc. Hydrogen, chlorine, and also the oxygen. Hydrogen, chlorine, and oxygen. So, the first definition comes with hydrogen. So, what is this? So, suppose one atom of nitrogen bonds with how many? What would be the number of hydrogen atom? What is the number of hydrogen atom and nitrogen atom makes bond? Then it will be called as its valency. So, it is the capacity of an atom to bond with another atom. What is the of an atom? Here specifically nitrogen is taken, and with another atom here, that is the hydrogen is taken. If one example, that is chlorine, if we take the example of chlorine, Cl. So, how many atoms of hydrogen bond with chlorine? We know the example of HCl, that is hydrochloric acid. Here only one hydrogen atom. So, the valency of chlorine is 1 here. Here nitrogen, one example of NH3. So, how many hydrogen atom? Here 3 hydrogen atom bonded with that. So, here the valency of the nitrogen is 3. So, in the HCl the valency of chlorine is 1. In NH3 the valency of the nitrogen is 3. Now, there is a difference, that is we already have bisected the ions into 2 parts, that is one is cationic charge, another one is anionic or positive and negative charge species. Now, which one will be called as positive and which one will be called as negative? Okay. This will be discussed later on, because it is the further part of the valency, because here nitrogen it is -3, here chlorine it is -1, this part, but here in rough it is the valency of chlorine here is 1, here it is in 3. Okay. In the same way, chlorine may also be taken as a reference for that. Suppose in one compound, that is phosphorus pentachloride, it is a name of a compound. Now, the formula for this, that is PCl5. Now, how many chlorine atom has bonded with the phosphorus atom? That is 5. So, here the valency of phosphorus is 5. So, everywhere we will calculate the capacity of the central atom. Here phosphorus is the central atom. In ammonia, here nitrogen was the central atom. Here in HCl, here chlorine was the central atom. So, in this way we are calculating the additive power of an atom with bonded with the another one atom is called as valency. Okay. So, today we will stop the discussion over here.